Hello everyone, I will discuss some more problems on the equivalent impedance point of view. So in that, next question is find the R equivalent across the AB for the network shown in the below figure. This is the given circuit. For suppose if we cut this circuit left portion, okay, this portion, if we cut this circuit, what is the remaining circuit? This is the remaining circuit. If we cut this left portion of this circuit, then you will get this circuit. If you observe here, same, this is also R equivalent. Okay, from if you see from here, this is also R equivalent. Okay, just we take out just these two resistors, but circuit is not changes. So this is R equivalent. So I'm replacing this entire circuit with R equivalent parallel to this circuit. Finally, you will get this circuit. If you observe this circuit, 10 ohm resistor and R equivalent are in parallel, and this resultant is series with this 10 ohms. So what is R equivalent now? R equivalent is equal to 10 plus 10 into R equivalent by 10 plus R equivalent. Okay, now what is R equivalent? 100 plus 10 R equivalent plus 10 R equivalent divided by 10 plus R equivalent. Okay, you will get finally R equivalent square minus 10 R equivalent minus 100 is equal to 0. If we solve this, R equivalent is equal to 16.18 ohms and another value is R equivalent equal to minus 6.18 ohms. So here we are considering only positive values. So this is R equivalent. Next question, find the R equivalent across the AB for the network shown in the below figure. This is the given circuit. This circuit is also looks like a previous problem. Okay, so if you cut here, from this it is R equivalent again. Okay, up to infinity. From this it is R equivalent. So this can be replaced with R equivalent. You will get this is 2 ohms, R equivalent 1 ohm. This is R equivalent. So this 2 ohms and R equivalent are in parallel, and this resultant is series with this 1 ohm. So what is R equivalent? We get R equivalent is equal to 1 plus 2 into R equivalent by 2 plus R equivalent. So the quadratic equation is R equivalent square minus R equivalent minus 2 is equal to 0. If we solve this equation, we will get R equivalent equal to 2 ohms and R equivalent equal to minus 1 ohm. So we consider only positive values. So this is R equivalent. Okay, neglect this value. Next question, find the R equivalent across the AB for the network shown in the below figure. This is the given circuit. Okay, here this is 5 ohms, but all these resistance values are 10 ohms. So how to solve this? To solve this type of circuits, okay, first of all, split these values. Okay, the circuit becomes, if you observe here, so I am splitting this 10 ohm resistor into two resistors, that is 5 ohms and 5 ohms. If two resistors are connected in series, then the equivalent is summation of two resistors. So 5 plus 5, you will get 10 ohms. So I am splitting this 10 ohms into 5 ohms, 5 ohms. Again, this 10 ohms is splitting into 5 ohms, 5 ohms. Similarly, here one more 10 ohms is there. So we can split into 5 ohms and 5 ohms. Now, cut this circuit up to here, that is left of this dotted line. Again, you will get same circuit. That means, so this is 5 ohm, this is 10 ohm. Again, this is 10 ohm, again 10 ohm, 10 ohm. So same circuit is repeating now. So same circuit is repeating. What happened? Here we can replace this entire circuit with R equivalent. So you will get circuit is you will get this circuit. Okay, if you observe here, these 5 ohms and R equivalent are in series. So what is equivalent? 5 plus R equivalent. Again, this 5 plus R equivalent is parallel with 10 ohms, and this total resultant is in series with 5 ohms. So you will get what is R equivalent? R equivalent is equal to 5 plus 10 into, so these two are in series. So 5 plus R equivalent divided by 10 plus 5 plus R equivalent. So here the quadratic equation is R equivalent square plus 15 R equivalent is equal to 5 R equivalent plus 75 plus 50 plus 10 R equivalent. Okay, this 15 R equivalent and this 5 plus 10, 15 R equivalent are cancelled. So you will get what is R equivalent? R equivalent is equal to root over 125 ohms. You will get that is 5 root 5, 11.18 ohms. For suppose in this problem, all resistors are replaced with inductors with the same value. That means 10 Henry, 10 Henry, 10 Henry, 10 Henry. Same procedure you can follow. So here answer is also L equivalent is equal to 16.18 Henry. Next question. Find the C equivalent across the AB for the network shown in the below figure. This is the given circuit. We can follow same method from the previous problems. That means cut the circuit from the left side of these dotted lines. You can replace and this entire circuit with C equivalent. From the right of this dotted line circuit, it look like C equivalent. Okay, so replace this entire circuit with C equivalent. This is the circuit. Now this 5 farad and this C equivalent are in parallel and resultant is series with 5 farad. So what is the C equivalent? C equivalent is equal to, so two capacitors are connected in parallel. Equivalent is summation of that two capacitors, and if it is parallel, C1 C2 by C1 plus C2. So you will get 5 into 5 plus C equivalent by 5 plus C equivalent. Okay, so this is the equivalent. Equivalent is C equivalent plus 5. So you will get quadratic equation is C equivalent square plus 5 C equivalent minus 25 is equal to 0. If we solve this quadratic equation, you will get C equivalent is equal to 3.09 farads and C equivalent is equal to minus 8.09 farads. So we considered only positive values and we neglect negative values. So this is the C equivalent value, that is 3.09 farads. Next question. Find current I in the following circuit. This is the given circuit. If you observe here, this node and this node are short circuited. That means these are at same potential. Okay, now this 12 ohms and 12 ohms are in series. Okay, these are connected in series and resultant is parallel with 12 ohms because this point and this point is same for this 12 ohm resistor and resultant of these two resistors. Okay, so these two resistors are connected in parallel. That means these 12 ohms and 12 ohms are in series. So resultant is, you will get one resistor and that resistor and this resistor are in parallel. Now this 12 ohms and 12 ohms are in series and this 12 ohms and 12 ohms are in series. So equivalent is 12 plus 12 because if two resistors are connected in series, then equivalent is summation of two resistors. So that is 12 plus 12, that equal to 24. Now circuit becomes, okay, this is the circuit. If we solve this resultant, that means this 12 and 12 are in series. So equivalent is 24. Okay, this resistor is connected like this. This is 24 ohms. This 24 and 12 ohms are in parallel. So this 24 and 12 ohms are in parallel. So parallel circuit R1 R2 by R1 plus R2. So 12 into 24 by 12 plus 24. If you solve this, you will get 8 ohms. So I write here. This resistance and this resistance are not changes. So I keep here. So let it be here I1. Okay. See here, this current is disappear because we are finding equivalent of these two. If you observe here, 8 ohms, 12 ohms and 12 ohms are in series. These are connected parallel across this 24 ohms. That means you can draw, this is on R equivalent. So this is total resistance. That means 24 and this is 8 plus 12, 20, 20 plus 12, 32. Okay, this is the I1. Now what is I1? I1 is equal to 24 by 32, that is 3 by 4 amperes. Now if you observe here, this thing, this is I1. I1 is equal to 3 by 4 amperes. 3 by 4 amperes. If you observe here, so just strike out this. So this is 24, this is 12. These two are in parallel. Okay. So here this is the total current. So you can, whenever two parallel resistors are there, we can apply current division rule. So what is the current flowing through this resistor? Opposite resistance, that is I is equal to 24 by 24 plus 12, total resistance into total current, that is I1. I1 means 3 by 4. If you solve this, you will get 1 by 2 amperes or 0.5 amperes. Okay, this is about the equivalent impedance point of view. Thank you for watching.